Today, I am going to have a brief idea on the liquid returning structures and its importance from the civil engineering aspects, designing these liquid returning structures as well as other heavy industry structures. So let's move ahead on this presentation on this liquid returning structures. So the today's webinar content, I will be discussing about the following things. Number one, first of all, I will be discussing about the introduction part. That is the what is the liquid returning structures, its aspects, and all these things I will be discussing. Where it has been actually used, what is the importance of these structures in present days engineering scenario as well as infrastructure scenarios. What is its types? After this overview portion, I will be discussing about the fundamentals of designing these liquid returning structures. Because since these liquid returning structures are leak prone structure as well as that is used for storing liquids, especially water, as well as some sort of areas it has been the corrosive nature of liquids is stored over there. So it is huge important from an engineering perspective to uh, take this structure design very seriously, and there is absolutely no chance of errors and ambiguities on the analysis procedure. So in the fundamental part, I'll be discussing about the design principles that will be followed or that has been followed for this liquid returning structure design and analysis part. Going to make a case study. I have prepared a case study for betterment or better understanding of the participants, how a sample, a very short sample, where we can see that how the structure has been designed and from which way the moment share has been calculated, and based on the same the reinforcement has been provided. So on this case study aspect, I'll be discussing on this portion. After that, the state of the art, because it is this liquid reading structure is evolved in a very ancient time. So by the time passes, these things are actually developed in many folds, and today's technology is coming, new technologies are coming up in this field. So there are lots of things that is the new possibilities into this field of this liquid reading structure design and analysis part. I'll be discussing on this about in the state of the art topic. And after that, I'll be able to give a brief idea on the evolution from this liquid reading structures from the earlier days, how it has been evolved into the present day phenomena or present day situations. And last but not least, what is the career prospects, which is the very important aspects for this, particularly this kind of designing. If one can gain the capabilities through proper understanding and make themselves competent in this field of design of this liquid returning structure, so how their career will move forward, what is the opportunities, what is the new things that they can learn, and their job profile. I'll be discussing about this into this career field. Introduction part, we can discuss that in today is the period of the rapid urbanization is we can observe in many countries as well as especially in our Indian context as well. So in the rapid urbanization context, lots of smart cities or town upgradation as well as locality upgradation is coming up. Lots of new municipalities has been formed, corporations have been formed. So in that new formations or new changes into the society, it is it is a matter of requirement that a centralized water treatment system is a mandatory things to cater the water needs as well as effluent needs for this centralized for the smart cities as well as this new urban cities. So centralized water treatment is a water treatment plant where the raw water from the sometimes from the surface ground surface water, or sometimes the groundwater has been pulled up and it has been treated and it has been stored into water returning structures, that is the or the liquid returning structures, and from there by some proper means, it is actually flowed to the nearby cities or towns where the people can get the treated water. So in that aspect, in the water treatment plant aspect, the liquid drilling structures is a very important structures, which is a major part of this water treatment. Some structures like I can name it like clarified, flash mixture, lots of underground and overground reservoir, which is required for the process of this water treatment throughout. So all these are liquid drilling structures, which is very big in nature and very important too in the process aspects. And in the other hand, the effluent treatment plant, that is ETP, it is a very important new technology or new thing that is coming up into the picture, especially for the industrial aspect, because our government are actually putting some clause on the several factory laws, factory bylaws, that the effluent that is discharged from a plant should be treated so that there is the contamination into the outside environment is very less, and sometimes if it is mandatory or it is necessary to drain some effluent out from the plant, it has to be properly treated so that a solid formation is formed from there, and the liquid part is get out from pull out from the waste, and it is recirculated in the system, so that there is a recirculating water system is also nowadays very popular into the industrial aspect. Have also requires lots of liquid drilling structures like thickeners are there, lots of thickeners, lots of tank storage tank, lots of drying beds, lots of sedimentation ponds, which is very critical for this effluent treatment scenarios. It is also a particular type of liquid drilling structure. So in this short introduction, I can say that this is a very important aspects of this liquid drilling structure in the coming future. Also, lots of the new things are coming up into this field. And so the following aspects of liquid drilling structures, which is to be learned by every practicing engineer who will be making their career into this domain. First of all, they need to understand the importance. I have already discussed some of the important aspects of the liquid drilling structure in the introduction slide. And after that, what is very important, then people have to understand the sizing calculation, because in sizing aspects it is very important how the sizing calculation is made. Suppose for a overhead tank, what will be the capacity from the overhead tank? That is a very crucial thing to decide. That depends upon the maximum daily demand, the average daily demand of a city, which is calculated based on rational formulas available in codes, as well as some textbooks are also there. In that demand, this size of overhead tanks has been calculated. Also, in some areas, fire demand is a major thing that needs to be taken care of in this overhead tanks. So sizing aspect is very important for this overhead tank. Also, some sedimentation ponds where the sewage is treated with mixed with some coagulants, or the raw water which is to be treated into a purified water is mixed with coagulants, which after that is going to pass through a long bed of sedimentation pond, where the sedimentation pond length and width is calculated is dependent on the settling velocity of the particle. So from the settling velocity aspect, the size of this pond is calculated. So that is very important part of this. So the sizing calculation is very important. And after the sizing is fixed, then comes the analysis and design part of this liquid drilling structures. Presently, we are professionally we are doing it in through AFEA, that is finite element analysis model. Lots of softwares like STAT. StatPro is very competent in this field of AFEA analysis of this liquid drilling structure. Sometimes SAP is also SAP 2000 is also used in this AFEA analysis. And in conventional approach for small tanks or for small pit-like structures, we use conventional approach. Conventional approach is we can use the Moody's chart. Also, there is some provisions or some charts are available in IS 3370/2009, from where we can get the moment shear coefficient, and based on the coefficient, we can calculate various moment shear values at different portion of the tank wall or raft, and based on the same, the design has been performed. Another thing is that the overhead water tank, it is also a very important and crucial thing to design or to consider, because first of all, this is a very important structure. If it fails its purpose, it is going to affect a huge population, as well as these structures are heavier in the upper side of its layout. So it is very much prone to attract seismic forces. So since its heads are heavy, lots of seismic horizontal force is coming into the top of the structures, and the structure is supported on a cylindrical shaft, which is actually taking the whole load of this water, as well as as well as should be sufficiently designed to cater the moments and shear that is coming from this seismic forces that is going to act mainly on the top of this tank. So from the design aspects, it is very important to consider all these things. Also, since these are very critical and slender structure, sometimes modal dynamic analysis needs to be performed. Wind effect also needs to be taken care of, dynamic wind effect. So and for the seismic effects, the modal analysis needs to be performed. This modal analysis is performed through LAM mass system into the stat probe, and from the LAM mass system, we are going to create a mode shape, various mode shape, which will be occurring on this overhead tank, and based on the same, natural frequency of the tank has been just judged with the maximum amount of mass participation factor. There is the mass, in which mode the mass is going to affect or the contribute to most in it. So by that is called the mass participation factor. So with based on this participation factor, the natural frequency is defined. So there are lots of procedures available into the standard StatPro and other softwares, where we can perform this modal analysis, and from this modal analysis we can calculate the natural frequency of the structure, and from this natural frequency we can calculate the various forces which is coming onto the shaft as well as into the top of the tank. Now, other important thing is the drawing and detailing. So that is a very critical aspect. Drawing is the language of an engineer. So some that is very important from an engineering perspective to make proper drawing with showing proper sizes, proper lap length, proper lap length, proper sizing, proper sizing, proper diameter, spacing, all these things to be mentioned in the drawing. From the detailing aspect, this is also important because, especially for the overhead tanks where the cutouts are there into the tanks, so there some sort of special detailing needs to be performed to transfer this stress suitably to the foundation. So this detailing aspect also needs to be reviewed with proper care. Now I am pointing out the design analysis phenomena of this LRS system, which is actually followed. So to understand this design and analysis of LRS, that is liquid drilling structure, first of all, one is to understand the behavior of the structure. Behavior of the structure into different loading conditions, that is very important from a practicing engineer to consider. In the right hand side, you can follow in figure 1, that is the clarified, which is actually used to treat raw water. The raw water is pumped intake channels or intake pumps from surface water, that is from river or it can be a huge reservoir. Reservoir means natural reservoir. So from that reservoir, the water is taken, or water is pumped, and it is mixed with coagulants. Coagulants. So in the flash mixture, after that, this flash mixture, the water is stored into this clarified, and where some agitators are there, which is continuously moving in a very slow speed, so that it is mixed properly with this coagulant, and the sediment and the soluble solids, and these are actually going to precipitate into this tank, and the clear water is transferred to the peripheral clear water channel. From there, it is taken to the further treatment process. So this clarificator, actually you can see in the figure 2, that is the empty condition. So after a certain use of this clarificator in the field condition, the precipitation actually, the solid particles are precipitates into the bottom of this tank. So it needs periodical cleaning. So when the cleaning cycle begins, so then the whole of the water that is stored in this clarificator needs to be pumped out. So in this case, it can be followed that one has to take two conditions of loading while designing this clarificator. That is, first of all, when the water is filled into this clarificator, and when the no water into the clarificator, that is whether it is when it is in empty condition. It is very critical for underground reservoirs where this loading condition have varied considerably. For example, during the construction stage, when a underground reservoir is going to be constructed, so in that case, only there will be outside earth pressure. There will be no inside water. Only outside earth pressure will be there. So the tension in the wall is coming into the outward direction of this wall. It may happen that sometimes it may happen for large underground structure, there may be not proper backfilling on the outside, and sometimes it is very evident from practical scenario that this type of tanks, during the construction stage, inside of the tank is filled with water, and if the outside is not backfilled properly, so the water pressure is coming from the inside of the tank, and it is the pressure, that is the tension, is coming into the inside of the wall. So this loading condition, this is different loading condition that is a structure is going to experience in its life cycle. That has to be properly judged by an engineer, and based on the same, the analysis have to be performed into different loading conditions. So for simplified analysis, for the simple tank analysis, we generally use the Moody's chart. I'll be discussing in the subsequent slide what is Moody's chart and how it is used to calculate the moment and shear values for this from this Moody's chart. And another thing which is most popular nowadays, that is the FEA, that is finite element analysis model. Each element, these tanks are modeled into StatPro or SAP, like a finite element model, plate element. In this plate element, we provide the actual loading conditions into this plate element, and after analysis result, we can get a plate stress at different level. From there, we can able to calculate the moment and shear values, and based on this moment and shear values, we will provide the effective reinforcement required for the section. Another thing which is very important, that is we can design this wall and raft of the LRS system as earlier. It is important consider this LRS design as untracked section. So in that case, we are going to limit the stress values of this concrete and steel at a certain level. So in that case, we usually see a huge section is coming up for the raft as well as wall. So after that, this crack design is coming to the picture, where we are allowing some crack into the outside or in the tension phase of the concrete, and the thickness are coming down a considerable extent, and it is very going to be very economical nowadays from the earlier designs of this untracked section. Another thing is that IS 3370/2009, that is the liquid treatment structure design code. So with this code, we have to comply
all this provision that is mentioned in this code during the design process. And there also the stress level is mentioned over there, the crack width calculation system is mentioned over there. So one need to comply all this provision which is mentioned within the IS 3370 during the design process. So in the movies chart, since I am discussing in the earlier slide, so there is the some few snaps I have taken from the Moody's chart. Mr. W.T. Moody in his water resource technical publication provided a book where some with some boundary condition as well as loading conditions from the top. This boundary different boundary condition can be seen. That is the top free, top hinged, 3H free, bottom. These 4 or 5 boundary conditions are there, and the bottoms are the different loading condition. That is the pressure coordinates of the wall elements. So different type of loading conditions are there. Based on these loading conditions, several charts have been developed into the this technical publication. Especially this rectangular part is taken for surcharge calculation, where there is surcharge load, and this triangular portion that is important for our liquid reading structure design, since it is in the liquid reading structures. This triangular pressure actually calculated for the wall aspect. So with these boundary conditions above and the loading conditions below, moment and shear values is calculated. One can see there is a typical sample I have taken. A by B is the ratio of the half of the width and the total height. So based on this ratio, one can obtain the various moment and shear coefficient for MX direction as well as MY direction. So once this moment is calculated based on these moments, if we can multiply with this P means the pressure ordinate at bottom, and B is the height of this wall. So with coefficient into multiplied by pressure ordinate and height square, we can able to easily find the moment coefficient or moment value for a wall, and also the reaction, that is the shear value, can be calculated with coefficient into pressure value and this height of this wall. So for the simple structure, we generally prefer to use this Moody's chart. In the right hand side, one can follow the sign convention that is used for calculating this moment and shear, because that is very crucial for one to understand the sign convention. Through sign convention, it is possible to identify the tension phase. What is the tension phase? What is the which one is the compression phase? Because for a fixed for a 3H fixed type of tank, if the pressure is coming from the outside, so from the outside of this in the wall junction, in the fixed stage there will be tension on the outside, but in the middle portion the tension will be on the inside of the structure. So it is very important to take this positive negative aspect, so that we can properly calculate this moment shear value and provide effective reinforcement as per requirement into the desired side. Crack width calculation is important, since as we are discussing earlier, uncracked design of liquid reading structure is not very popular, because it's actually restrict the concrete and steel stress to a considerable extent. So the wall thickness as well as raft thickness is going to be very high, and that is why it is going to be very costly structures and uneconomical too. So in that case, nowadays this cracked section calculation for LRS is very. In this process, we are calculating the crack width in the tension phase. In the tension phase of the wall or rack, by the following formula. This formula is already available in IS 456 2000. Also in IS 3370, these formulas are given. So based on these formulas, we can able to calculate the surface crack width in the tension phase. So this is restricted to zero point 0.2 mm as per IS 3370 2009. So if with the moment value we can restrict our surface crack within a value of 0.2 millimeter. Now the code says that that is allowable, and in this way the structures are made more economical nowadays, and it is very feasible too. So in the formula, one can easily observe that ACR, that is WCR, it is the width of the crack. That is the crack width, practically. The distance from the point, from the outside point to the nearest longitudinal bar is calculated. Minimum cover to longitudinal bar is also calculated. Overall depth of the member and depth of the neutral axis is calculated. From this, together with to calculate this epsilon m value, we will use this formula. With these two formulas, we are going to calculate this WCR, that is the crack width, and with this crack width, if we are able to limit its value to zero point 0.2 millimeter, so then the section will be safe from the design perspective. So nowadays, this is the general trend to consider for crack with calculation. This is the crack design concept. Now coming to detail of this FE analysis. So that is a very simple sort of tank. That is a case study I am talking about. One case study, there is this structure. There is a lifting pump house which has been used in one project. This structure is designed by me. So there, this is the lifting well. So from a slime pond, this water is taken into this sump like things, which is nothing but a underground tank, and into this from this sump, this water is taken with this pump, and after that, through this pump, the further there is further delivery lines from where this water is transferred to the further treatment process. So where one can see this in figure 2, I have modeled these structures like this. Here the purple color thing is the plate element that I have modeled, and this blue color thing is the frame structure, frame of the pump house. That is this part. There is a column. It is taken from the wall, supported from the wall, and that is the root beam. There is the primary beams are there, and in between is the secondary beam. So, and there is into this floor portion, I have given this two beams, which is to take the pump load, which is going to be considered for this model. And after analysis, after applying these water loads from the inside, and when the inside water is out, some say the sluice gates are closed and water is pumped out, so there will be water at the outside. So that is the loading condition 1. Sometimes it so happen that outside water is nil, the sluice gates are closed, inside water is high. So there is a second loading condition. One can easily follow that from the first case, when the water is outside and there is no water inside, there will be outside tension. And whereas in the second option, where inside there is water and outside there is no water, there will be inside tension. So this is the two loading conditions that we have to give into this stat, and from the stat, one can able to see this figure 3, that is the plate stress contours. One can easily follow the stress contours are there. Instead, we can easily able to make the stress contour very easily, and from where um, we can have a look on the deflection criteria, deflection pattern of this structure, and we can able to calculate various moment shear values at different sections. So that is the detailing part. When we are going to use this stat, that will be very relevant also, and very useful also for designing this kind of elements. Now, in the state of the art things, I want to discuss this about the two major aspect. That is this desalination plant. Desalination plant is very important plant nowadays. That is a state of the art RO plant with modern desalination and demineralization facilities. It is coming into the sea-based cities. One desalination unit has been proposed for our Chennai module also. and it is very popular nowadays for various cities abroad, where basically the cities are actually dependent on rainwater storage initially, because other water, the groundwater is saline in nature. So in earlier days, this RO process, that is from saline water to make purified water, is very costly in nature. But now in the technology advancement, these things are actually now can be produced in a economical way. So this new type of RO plants are coming up into lots of cities, especially the sea side cities in abroad as well as in Indian context too. These are the new things that is coming up, and this new technology is lots of structure, liquid returning structure involvement here. Especially the FRP tanks is used here, but large concrete tanks is also very popular in these desalinating plants to store purified liquids as well as raw saline water also. And the another thing is that the various type of water returning structure. Nowadays, this water returning structure is very important. In it is cases it is actually used to describe as a landmark for a city, and so various architectural aspects are going to implement into these water tanks, and which is making this tank, the design of this tanks, very critical and challenging too. So there in figure 3 or in figure 5, one can see that there is not a conventional type of water storage tank shape. So to give it a new look, architects actually providing lots of outside skirting works. Also, its shape is different from the conventional shape. So it is actually put major challenge to the structural engineers for its stability and economical perspective too. So that is the modern trend of this in this water purified section. So that is coming up. One needs to understand properly all these things and learn these new technologies as well. Now, concentrating briefly concentrating on the evolution part. So, lots of man-made reservoirs such as steep well and cisterns are we have seen this as early as around 3000 to 1500 BC. But in this the reservoir quality in this reservoir, the quality is a big issue because this leakage of this reservoir. So since the crack is not properly addressed into this reservoirs, man-made reservoirs, so this water is contaminated often, and several disease outbreak from these tanks. And after that, the system were designed as underground reservoir, so the somewhat this level of contamination is reduced. So in a further development, the small size water tanks are constructed in households. After that, after that, this improvement of this process, modern treatment plants and concrete tanks is very inevitable, and it is coming up in a centralized system rather than a building wise system. So in a centralized water system, that has been treated, that is purified, and that is distributed through the conventional channels. From this channel, outside every household has a connection from this inside channels, and and the water is distributed to the household. So, coming into this carrier prospect, so as per National Water Mission, this promotion of water purification and desalination is one of the prime goals of the government. So, so since it is government of India is putting more importance into this field, the demand for engineers, especially civil engineer, into this structural design of this liquid returning structure as well as this water treatment plant design is is on the requirement of the engineer is very very high. People are actually since there is a lack of professional knowledgeable person into this field, so there is a huge opportunity available into this field of water and wastewater system. Especially the companies are looking for design experienced professionals who is actually very conversant with this liquid drilling structure design as well as its aspects. Also, the freshers who are actually just pass out from the college, the new companies who is actually emphasizing their business module onto this water wastewater segment. They are also looking for a basic knowledge into the design field of this wastewater and water treatment and effluent treatment sector. So, from a career aspect, every engineering professional who is actually growing into their career, also the students who are actually just freshly graduating from from an institution, it is very very important for all of them to take this opportunity or to put emphasis on this liquid drilling structure design aspects, its design, its construction also is very very important to take consideration, because for the shaft type water tanks, slip form shuttering, one can able to see that there is a very modern aspect of the slip form shuttering where the shaft has been constructed. It is also been very popular for chimney construction as well. So these things are very very challenging in nature, and it is a very new thing to learn. So if one can properly make themselves knowledgeable into this field, into the design field, into this analysis design field, detailing field, and overall knowledge, if they can able to gain from proper literature and or other it will important as well as very very useful for them for a bright career into this field. So that is from my side, on the a brief idea on this liquid drilling structure design aspects overview and all. So thank you.